Hello, ever-learning scholars. It's Mr. Alan again. I'm your host for this science lesson. I want you to have fun learning in our online virtual classroom. Okay, last time you treated the topic separation techniques. So I want to do a quick catch-up class or revision to help us refresh our memories on what separation of mixtures is all about. In my next slide, you're going to be seeing the unit for today's class is called separation of mixtures. In a nutshell, you can call it separation technique. Separation of mixtures takes place in our environment, especially starting from the home, in your mother's kitchen. Separation takes place in industries, in factories where production is made. It takes place in mining sites. It takes place in oceans and many aspects of nature. Now, separation is very important because if you must have materials to be useful to you for one purpose or the other, or for one daily use of everyday materials, then there need to be a separation. Separation is simply the technique we use to separate two or more mixtures that are physically combined. Take note, they must be physically combined, because chemically combined substances or mixtures cannot be separated. We call such reactions irreversible reactions. While substances we can separate using physical means through separation techniques is called reversible reaction. It means they can be taken back to their original form or state. Also note that in this lesson, never forget the formula: solute plus solvent is equal to solution. Solute plus solvent is equal to solution. A solute is simply a solid substance or material. A solvent is simply a liquid substance or material. Then when you have a combination of a solid and a liquid material, whether it dissolves in it or not, you call the product a solution. For instance, if I dissolve salt in water and stir, after a while you won't get to see the salt again. It will mix with the water in such a way that they become of the same phase. We call it a homogeneous mixture. So in that case, you say you have a solution of salt. If you do same using sugar in water dissolved and stirred, you call it a solution of sugar, and many more solutions we have at home. What about your mother's kitchen? When mommy is cooking and she drops some ingredients like the Maggi cube inside a soup, when you stir, you don't get to see the Maggi again. It mixes up with the soup. In that case, it's a solution of Maggi because there is liquid there, the water, then the solute is the Maggi itself. Alright, so we're learning to investigate the separation of mixtures, and I'll be looking at 4 separation techniques in this lesson. I'll be looking at filtration method, I'll be looking at separating funnel method, I'll be looking at magnetization method, and the sieving method. Alright, let's go. Okay, so in this picture I have the filtration method of separation. In this case, you have a mixture of an insoluble solute and one solvent. So what we are trying to say here is that for filtration technique, you require apparatus like the beaker, where you have your solvent or liquid. You have the funnel, you have the filter paper. The filter paper is folded into a cone shape and inserted into the funnel. Then you need another container or beaker at the base of the funnel that is clamped to a retort stand, as you can see in the picture here. Then also we have the base where the container stays. Then when the mixture is put in a container, for instance a mixture of sand and water, sand is an insoluble solute or solid because it doesn't dissolve in water. Then the solvent is the water. Then when you pour it over the funnel into the filter paper, you allow the water to drip down into the container at the base. After a short while, you have 2 separate substances. Now the sand will be left behind in the beaker above here, while the water will be collected in the container below. In that case, separation through filtration has taken place. Moving to the next slide, I have the magnetization method of separation. In magnetization method of separation is the separation technique where you use a magnet to separate a mixture of 2 solutes. When I say 2 solutes, I mean 2 solids coming together in a container. So in this picture, You have a substance known as sulfur. Sulfur is a powdery yellow substance in nature. It's an element in nature. Then we have iron filings. Iron filings are tiny bits of metals that have been grinded into pieces and mixed with sulfur. Then how do you separate it using magnetization method? You get a magnet and move it over the surface of the container that has the iron and the sulfur mixture. After a while, all the metals will be attracted to the magnet because of the force of magnetism, or the magnetic force of attraction on the metals, and it takes out all the iron filings from it, having a separate mixture of iron filings on the magnet, leaving behind the sulfur in the container. You can also do this using sand and paper clips, or affix pins, or metal nails or screws, where you mix the sand and the metal, and when you have your magnet go over it, at the end of the day, the metal is picked by the magnet, leaving behind the solid. By so doing, separation technique has taken place using magnetization method. Now, another method here is the sieving method. It's simply a simple method that is used in everyday life, especially at home when mommy prepares certain food substances. In this picture, the sieving method shows how we had to pour the mixture into a sieve over a beaker. When we shook the mixture through, everything fell into the beaker, but not the rice. When it was just the rice left, we poured it all into a small beaker. Now, this is a mixture of rice and sand in a container poured into a sieve. Then what you are to do is to shake the sieve over another empty container. Now the smaller solute or smaller particle will go down the mesh of the sieve, leaving behind the bigger particles known as the rice. So at the end of the day, you have a separate component of rice left behind in the sieve. Then the sand will be collected in the empty container. This is used in everyday life to separate mixtures. For instance, if at home maize is processed into corn flour, it is sieved using a sieve at home to remove the chaff from the main food substance that's going to be prepared as cornmeal at home for feeding. Even in the processing of pap is made from maize, is made from millet or sorghum. Now when it is grinded by the grinding engine, it comes with a paste and some liquids in it. Now to have the main paste that is formed into pap, it is poured into a cloth sieve with a mesh, and it is pressed out of the sieve. The main content is pressed out and it drips into an empty container, leaving behind the chaff in the sieve, and it is disposed afterwards or given to flocks for feeding. Next slide. This is called the separating funnel method. This was done in the lab some time ago with you. This technique simply is a technique used to separate a mixture of two immiscible liquids. By immiscible, we mean liquids that cannot mix. This is a solution of liquids. For instance, when I have water and kerosene, or water and oil. Now oil is lighter than water, water is denser than oil. So when you have a mixture of oil and water, for instance vegetable oil, the vegetable oil will float at the surface of the water. When we have this mixture, we shake very well, we pour it into a separating funnel as you can see here, and it is attached to a retort stand and clamp to hold it in position with a beaker at the base. It has a tap that you open gradually to allow the denser liquid, which is water, to drip down. On this picture you can see it has two surfaces. We have the liquid, which is water, down. You can see a mark here, there's a mark here, and the lighter liquid, which is vegetable oil, is floating on the surface. That's why you see a separate layer. Now when these two separate layers are formed, then you open the tap gradually until the water drips down. As soon as it gets close to the lighter liquid, you quickly close the tap, and you have a separate component of water in the container and the oil left in the separating funnel. As a result, you've succeeded in separating this mixture. So this is how the separating funnel is used. You can pause this video and read this part to understand more on how the separating funnel works. Now, going on to other forms of separation, this is just to remind you of the evaporation method, where heat is applied to a mixture of a miscible solute in a liquid, and it is heated until the liquid escapes to the atmosphere, leaving behind the solid. Example, salt dissolved in water can be recovered using this method of evaporation. And there's also a method called distillation, where you separate two liquids that have close boiling points, for example alcohol and water. The alcohol will evaporate first and collected in another container, leaving behind the water. This is a class activity. Take a look at this picture. We have a mixture of salt water, paper clip and paper, vegetables and soup, nails and sand. We have three separation techniques here: funnel, separating funnel method, magnetization method, and boiling method. Use lines to match or just try to get a match for the particular or appropriate separation technique for each of these mixtures we have above. That brings me to the end of this lesson. I hope you found it interesting and as a way of reflecting on what you've done. Thank you for your audience. I'll see you in my next learning segment. Bye for now from Zoologist Alan.